All right, this is a review from our middle of the unit on transformations. We're going to be testing tomorrow. So this is the transformations mid-unit assessment review. This review, as we are reviewing in December of 2021, is a really important review because this entire lesson has been learned with students watching videos as I have been gone. So I want you to kind of pre-test yourself. Throughout this video, I'm going to ask you to pause the video as you complete a problem, pretending like it's a test question. And then we'll go over it together to see how you would have done if it were a test question. That way you can kind of learn from those mistakes in preparation for tomorrow's test. So, with that in mind, here's problem number 1. It says select all the triangles that can be rotated to match up with triangle 1. Here's triangle 1. What are all of the triangles that can be rotated to match up with triangle 1? Pause the recording, give yourself a chance to answer this question. Resume only when you've given yourself time to answer it. Okay, and we're back. Let's go over it. Let's just go over it one at a time. A, can we rotate triangle 1 to become A, or can A rotate to become triangle 1? Brighton, what are your thoughts? Because what? Sorry? A reflection, yes. So you noticed a mirror, but remember a mirror is a reflection, so we're going to use that math word reflection. Yes, you're right. This is a reflection. I can translate it and reflect it, or I could probably even just find a mirror line or a line of reflection in between. But A is a reflection, not a rotation. So not that one. What about B? Is B going to work? Okay. Everyone's nodding yes. Then prove it to me. Let's go through the details. Even though the problem doesn't ask it, this is good study for the test. If it's a rotation, what is the center of rotation? What would that center of rotation be? Yep, this is why we're going over this. This is what you need to be able to answer on the test. Addie. Go touch it on the board. Go show me what you think it is. Yeah, exactly. It's where both of those triangles are touching. It would have to spin around this point right here, right? So that's the center of rotation. Now, what is the angle of rotation? Again, you do need to be able to do this for the test, so test yourself out now. What's that angle of rotation? Bryn, it is 90 degrees, so here's how we're going to do this. We found the center. Whether you're going from B to triangle 1 or triangle 1 to B, either way, it doesn't matter. Notice that this side right here rotates and becomes this side. Or vice versa, this side rotates and becomes that side. If you focus on just one piece at a time, can you now see the angle that it changed? Yeah. B rotated that amount. That's a 90-degree rotation. What direction did it go? If it was B rotating to triangle 1, what direction did it go? Andrew? Clockwise, exactly. Now, it didn't ask you to do that on the problem, but just good things to think about and study since that will be on the test. All right, so B, yes, B is a rotation. And we proved it by showing the angle of rotation, the center of rotation, described that whole thing. Let's go to C. Is C a rotation? I'm seeing heads shake. Why? Why is it not? Talk to me about it. If you're going to shake your head, explain it. Let's go to Brighton this time. That's a good question. Does the placement matter? Yeah, because if we have to change the placement, what kind of transformation is that? It's a translation, exactly. So that can move without rotating at all. It's just a translation, right? That being said, if I translated it, could I then unnecessarily rotate it 360 degrees and have it land back on itself? Yeah, is that necessary really? No, so I'm going to say no on that one. All right, let's go over D then. Is D, can we rotate D so that it lands on triangle 1 or vice versa? Triangle 1 landing on D. Andrew, what are your thoughts there? Okay, it's just a reflection. That is actually incorrect. And I'm so glad that you made that mistake. I knew that mistake was going to be a common one because especially when it's rotated 180 degrees, it can kind of look like a reflection. But Andrew, if it was a reflection, let's just say the mirror line is probably somewhere around there if it is a reflection, right? Okay. Now look at this. If this is staring straight into the mirror, It would be staring straight back. That looks good. But what about this? This angled side here would be staring straight into the mirror. And what would be staring straight back? The angled piece. Do you see now how it's not a reflection? So the best way to do these types of problems is get out your tracing paper and use it. If you end up having to flip the paper over, that's a reflection. This one, though, what would we have to do with that tracing paper? Would rotate 180 degrees. Can you see that now? Okay, this one is a rotation. Where would that center of rotation be? Who can see? Where would that center of rotation be? Go up and touch it, Aiden. Go give it a try. Give it a try. No, that's a good guess. So if we're starting right here on D, or even right here on triangle 1, and we're trying to rotate it so it becomes D, Brig, you're close up to the board. Go give it one more try. Let's have one more guess before I show you. Like if we had it traced on our paper and we wanted to spin that paper so it landed here, yeah, we'd have to poke our hole right through here, and we could spin that tracing paper around and it would land right there. Now again, this isn't geometry software, but the fact that I can pick up this triangle and spin it, and then of course I would have to move it into place, but all I really truly had to do was spin it, that tells me that it is indeed a rotation. Okay, rotation, we found that center and it rotated 180 degrees. Okay, the next one. You guys had a homework problem that was kind of sort of similar to this that most of you guys did completely wrong because you just see, oh, A, B, C, D, and you get overwhelmed by looking at all of these things that you don't realize just how simple it is. Please just baby step it. Start with A. Plot and label these points. Can you find A, which is over 2 and up 1, and put it down and then label A? Yeah, just do it one step at a time. After you complete A, then go through B, then go through C. And if you just baby step it, it's going to be really easy. I'm going to help with the first one right now, and then I'm going to pause and have you guys do B, C, D, and E. A is 2, 1. That's going to be over 2, up 1. Labeling that A. B is -5, -1. So that's going to be back 5 and then down 1. Labeling that B. C, -7, 2. So back 7, up 2, C, and D is 4, -2, so +4, and then down -2, and labeling that one D. There, I helped you out with A. Now just go one step at a time, do B. Reflect A over the x-axis, label it A prime, find the coordinates, and repeat that for each parts B, C, D, and E. Gonna pause the recording, and we'll go over this in about 60 to 90 seconds is all it really should take. Pause the recording now. All right, let's check it. If this were a test, did you get it correct? It says reflect point A over the x-axis. Which one's the x-axis? This one, it's labeled for you. So if this is A, and this is the mirror, or that line of reflection, how do those mirrors work? Here's A, one step away from the mirror, looking straight into the mirror, so the reflection is going to be one step away, staring straight back. There's our new point, and we're going to call it A prime. Now that we have plotted it and we know where it is, now we can write the coordinates. And the coordinates are 2, -1. If that were a test, would you have gotten it correct? Some of you are ready. Some of you were doing some last-minute studying just now, weren't you? Next one. Reflect point B over the y-axis. B is reflected over the y-axis. Here's B. Here's the y-axis. So if this is that mirror, B is 5 steps away, staring straight into the mirror. So where's the reflection going to be? 5 steps away, staring straight back. What are we going to call this point? B prime. What are the coordinates of that point? Brighton? Yeah, 5, -1. Great job. Okay, D. D says rotate C 90 degrees counterclockwise. Now those other two, the reflections, in my opinion, the reflections are fairly easy to do without needing tracing paper, unless it's a weird, like slanted sort of a line. But rotations are a little bit more difficult. It's a lot easier on a rotation if you use the tracing paper. But I also want to give you another strategy. Imagine if point C were part of a triangle. I'm going to turn this into a triangle. If this were a triangle whose base is on the x-axis and you rotated it 90 degrees counterclockwise, could you figure out where that triangle is? Yeah, it's pretty easy once you visualize it that way, right? See if you can figure out where point C is. I'm going to pause the recording for just a second. And then I will also show you how you can do it with tracing paper, but I want you to see if you can figure out where that point is going to be. All right, like I said, I feel like rotations are more easily done with tracing paper. So here I've kind of got some tracing paper modeled. Notice that I've got my C traced on the tracing paper. I'm going to be spinning it around this point, and so I have encouraged in the past, draw a plus sign through that center of rotation. That way you can keep track of how much you have rotated it. Okay, so now I'm going to rotate that. Again, poked my hole through this, and I'm going to be spinning my tracing paper around this point. So as I do that, going 90 degrees, the plus sign in that middle helps me keep track of when I've gone 90 degrees. There's that 90 degrees, and you can see where that point is now. Right here, and we're going to call that point C prime. What are the coordinates of that point? Looks like we went -2, -7. You guys get the same thing? Okay, nicely done. I'm going to move my tracing paper back out of the way. E says translate D 4 units to the right and 2 units down. Label that point D prime. Yes, Aiden. Okay, so if we're going 4 units to the right, I'm starting here, and I'm going 1, 2, 3, 4 to the right, and down 2. Now that I've got it plotted in its new position, label it D prime, and the coordinates are, go ahead now, Aiden. Got it. Well, describe where to put it by explaining those coordinates, please, Emily. 8, -4. You got it. Okay, so not too hard, was it? Especially if you just go one step at a time. Let's move on to number 3. Again, treat this as if it were a test question. If it were a test question, would you be able to answer it? Pause the recording, give it a try. Students in class are going to give it a try, and then we will go over it. Okay, who wants to give it a try? Let's go. Kaden. You think right. Tell me why it's 100. Wait, what did you say? No, it is not 131. I feel like you used a protractor. You should not have used a protractor. You should have used the mathematical relationships that we described. Do you know those mathematical relationships, Gavin? It's not 90. Definitely not 90. Let's go to Bryn. Bryn, did you watch the videos? Can you describe the mathematical relationship? Yes, pause there. One of the most easiest things, do you see the straight line, the straight angle? What do you know about a straight line? Bryn just reminded you in case you forgot. It's 180 degrees. Thank you, Bryn. Bryn, I so appreciate you watching the previous videos. Continue, Bryn. What else do you know? Now that we know that that's 180 degrees, what else? Yeah, exactly. This whole straight line or straight angle is 180 degrees. This much is taken up here by 50 degrees, so what's the remaining part? 130 degrees. No need for a protractor. The reason why you were off because of the protractor is because of the thickness of the lines and human error in measurement. 130 degrees, no protractor needed. Okay, we have answered A. Here's what we need to say. It's 130 degrees. How do we know? Well, the diagram kind of shows us, but I'm going to say, let's see, we're going to say CED is 180 degrees. 50 degrees is taken up by angle AEC. So I know that the rest is 130. That's a good enough explanation. Now that we've talked about that, does that ring a bell to anyone else? So maybe a few others watched the videos and just forgot, maybe? Okay. Now, part B. What's the measure of angle DEB? Give it a try, Andrew. How do you know that? Yes, I'm so proud of you. You didn't need to, so let's back up for just a second. He knew that because of another property, Andrew. Bonus points. Do you know the name of that property? Okay. The fact that you knew it is still pretty good, and I'm still pretty impressed. Fun fact, could we have also used the straight angle relationship like before? Yeah, this is still a straight line, so a straight angle, 180 degrees, 130 of it is here, so the remaining is 50. So we could continue to use that relationship. You don't have to, though, because this relationship here, it's called vertical angles. Does that ring a bell at all? Fun fact, this was lesson 9 just a couple lessons ago. Like, as in pretty recent. So, just saying. $50 degrees because vertical angles are congruent. These are vertical angles. Another way to prove this, as we did on that previous video, I'm going to rotate this figure. Again, remembering that this is not geometry software, so it doesn't work out perfectly. I'm going to have to make an adjustment after. But I'm going to rotate so that this lands back on itself, using this as a center. And watch what happens when I do that. Come on, there we go. Oh, do you notice how that angle that was over here now landed perfectly right here? Yeah, that's how we know that vertical angles are congruent. Now, take a look at number 4. Are you ready to do number 4? Get it done. Students in class basically burst into tears when I had them do this problem. But really, does it look big and long and scary and complicated? Now look, does it look big, long, scary, and complicated? Doesn't that look basically the same as the problem right up above it? Yeah. And now what if I cover up the other side? Does that look big and scary and long and complicated, or pretty dang easy? So, am I asking you to do a couple of things at once? Yeah. But is it really any different than the problem up above it? No. So stop crying. Just get to work and finish that problem as homework. All right, and here's the next one. Number 5, here's 2 triangles. Describe a sequence of transformations that will take triangle ABC to triangle FED. As I checked your assignments in Canvas and I checked your homework walking around the room, I saw that this was a serious struggle. So can I have all eyes on the screen, please? I need detail. I need to know exactly what I need to do in order to get it over here. So don't just say move it over. Move it over how much? And don't even just say move. Use the proper mathematical vocabulary. Maybe we need to spin it. Only if we did need to spin it, you are not going to say spin, you're going to say rotate. And you're going to tell me what the center of rotation is and what the angle of rotation is. And if it's a reflection, you're not just going to say mirror it. right? You're going to give me all the details, like where is the line of reflection, etc. So pause the recording, try it as if it were a test question, and then we'll go over it in just a second. Okay, so even though when you're doing this for your homework or doing this on the test, I want really, really specifics, all the details. Right now, just be general. What are some things that we would need to do? Brighton, just in general, don't give me the specifics. Okay, so we're going to have to shift it over. Yes, so that means we're going to have to translate it, right? Okay, what else? Okay, so again, that's all part of the translation. I don't need the specifics. Remember, I just need it general. We need to shift it, which means we're translating. What else needs to happen after it's translated? That's Miley over there. It needs to be flipped. Now, the proper way of saying it needs to be flipped is a reflection. Exactly. So I know that I'm going to need to do those two things. Now where it's time to be really specific and precise. How am I going to do those things? I just want to go with majority rules. How many of you guys did the reflection first? Raise your hand. Okay. How many of you did the translation first? Okay, most of you did the reflection, so let's do reflection first. When I'm talking about a reflection, I need to describe the line of reflection. So if I'm describing the line of reflection, that's where is that mirror? Where is the mirror? Who can just kind of try and describe? Allie, give it a try. Right in the middle of them. Okay, yeah. Now, not everybody would try and do it right in the middle. Some might try and do it right here, and then they'd have to translate it a little bit more, but you see it would have to be right in the middle, so that's good. There wasn't a line there already, so I drew the line, and I'm going to label the line. Let's just call it M. And now that I've done that, now I can describe that reflection. So I would say reflect. I'm not saying flip or mirror. I'm using the proper mathematical vocabulary. Reflect triangle, ABC, over this line that I just drew and labeled over line M. Now when I do that, it's going to be like this. Flip left and right, but it's actually going to end up right here, right? Okay, good. Now, what else needs to happen? What else needs to happen? Is that Gavin's hand? Go ahead, Gavin. Yes. Shift down how much? 2. Only instead of saying shift, what's the proper mathematical term? Translate. Yes, we would translate then. Translate 2 units down. Okay, did you do it different? Probably. Did you translate it first and then reflect it? Yeah. And depending on where you translated it, that might affect the reflection. So you don't have to have the exact same thing written down and you could still possibly get it correct. Okay, this is just what I'm doing to make sure that you know all of the pieces of information that we would need. The rest of this is a lot like the other worksheet that you guys had that you said that you really enjoyed, that you had a good time with. So I don't think I need to go over a lot of these ones. I want to go over probably 1 and 2, and then maybe 5 and 6. I don't even think I need to go over 5 and 6. Let's just skip down to 5 and 6 real quick. Please notice it still is the same thing. We're finding the coordinates though, just like we did a few problems ago. Find the coordinates of the point. I'm not rotating or translating a whole shape now. Are your eyes on the screen? I feel like you lost what you were supposed to be doing, which was listening to me. Thank you. We're not doing a whole entire figure. It's just a single point. So with this single point, we need to rotate it 90 degrees counterclockwise about the origin. Remember, I gave you strategies for that. Maybe turn it into a triangle, and then once it's turned into a triangle, wouldn't it be easier to envision where it's going to be when it's rotated? Yeah. Or could we also just use our tracing paper? Yeah. Once we have rotated it, can you write down the coordinates? Also yes. Okay. So it's the same thing that we've already done. It's just with this single point. So 5, 6, and 7 and 8, it's just that single point. In ways, it's even easier because it's not a whole entire figure. Okay. 9, 10, 11, and 12, you're doing the transformation that it says to do. 1, 2, 3, and 4, the transformation has taken place. You need to describe it. I want to try and focus on 1 and 2. We have a few minutes left before it's time to clean up. So I want to try and do 1 and 2. But again, pause it, give it a try first, and then we'll go over it together. All right, we're coming back together. What's happening in number 1? Write that rule. I want all the detail, all the information. Aiden. It is a reflection, but you can't just say reflection. Whenever we're describing a reflection, we need more information. Okay, keep going then. Great. Yes, fantastic. It's a reflection, yes. And after it's reflected, then we have to do a translation. Or there's something else that we can do. But yes, let's do it that way. 2 different things need to happen. We're reflecting over what line? Yes, reflection over x-axis. And when I reflect it over the x-axis, let's see where it's going to be. That's going to be, let's see, 2 away. So the reflection is going to be 2 away, right? This one's 1, 2, 3, 4 away. So the reflection is going to be 1, 2, 3, 4 away, etc. So that's where the image is going to be when it's reflected. So what do I need to do now to get it into place? Aiden, you said we need to now? Yeah, move it down. What's the way of saying it? Move it down. Nope, not slide. Translate. Yep, then translate down 2 units. There is another way we could have done it. Does anyone see what else we could have done? What if we just move the mirror line? What if instead of the mirror line or the line of reflection being X, what if it was right here? Could that also have worked? Yeah. What I would have to do is maybe call that line L and then just say reflect over line L. 2 ways that we could have done it. Either way, we're doing all the details, all the information. Okay, last one. Is this a reflection or a rotation? Brighton? It is not a reflection. It is not a reflection. That's why I put it on there, because a lot of times students see rotations like this and they think that it's a reflection, but it's really a rotation of Brig. How much? Yes, it's a rotation 180 degrees about the origin. And again, that's all the information I would need to include. Stating that it's a rotation, that it's going 180 degrees, clockwise or counterclockwise. Remember, 180 degrees is the one that doesn't matter if we say a direction. 180 degrees around the origin. Make sure you describe the center. Anything you have not yet completed in class is homework in preparation for tomorrow's test. That's it for today. Thanks for watching, and we'll see you next time.